Hello everyone, let's look at some important definitions with waves. The first definition, the first important term is called as wavelength. Because when we define a wave, we need to define in terms of certain parameters. For example, look at bulb or look at light. We have light of different colors. We have a red color bulb, red color light, blue color, and different colors. Now, something is different between these colors. So the difference is understood in terms of frequency or wavelength. So let's define the first term called as wavelength. Now wavelength we can define both for transverse as well as for longitudinal waves. In case of transverse wave, we can say it is the distance between two successive. This is very important. It is the distance between two successive crest or trough. In this case, this point C1 is a crest and C2 is a crest. We can mark on a point here called as C3. Even C3 would be a crest. The distance between any two successive crests is called as wavelength. Which means even here, distance between point C2 and C3 would be its wavelength only. Or we can define in terms of troughs also. So wavelength is the distance between two consecutive troughs. T1 and T2 are taken as two troughs. So distance between T1 and T2 would be lambda. Keep in mind that it is this distance only, it is not the length of the wave. Length of the wave is not the wavelength, rather it is the distance which is horizontal distance between two points. Now different waves will have different wavelength. For example, imagine the wavelengths in case of a string, or think of wavelength produced on a water surface, or think for example like tsunamis. Each of this will have different wavelength. Wavelength is a very important characteristics which tells how a wave would behave or how a wave would travel in a given medium. And its symbol is called as lambda, which is a Greek alphabet. And since it is distance, wavelength is measured in meter. The second definition, or we can define wavelength only for a longitudinal wave also. So for a longitudinal wave, it is defined as the distance between two successive compressions or rarefactions. Example, if you look at this as one point of compression and this as the next point of the next compression, so distance between this and this would be lambda. Similarly, if you look at this as the starting point of one rarefaction and this also starting point of another rarefaction, since these are successive, these are continuous, distance between these two rarefactions is called as wavelength. The second definition is called as time period. Now time period can be defined many ways. One way what is given here is this time taken by the wave to traverse a distance equal to the wavelength. That's called as time period. For example, let's take a wave whose wavelength, that is distance between two successive crest, is 5 meter. A very big wave, it's 5 meter. So if we have a point, we have an opening here, and if the wave is passing through the opening, so it's passing through the opening, then what you can do here is, if we turn on our timer, and if you count the time, then how long it takes for one wave to pass through. That is, in this case, call this as say point O, and this as say point A, this is point B. Then this is one wave. One wave contains a complete part of the wave. In this case, starting from here, we'll go back to the previous definition and see it. In this case, if you start from some point here, if you have a reference point, if you mark few points here, say a point O, a point A, a point B. So this O, A and A to B, this is one wave. So one wave means it contains the complete one crest and then one trough. That's called as one wave. So if you want to find time period, we can say it is the time taken for one complete wave to pass through this given point. So if you have some opening here, and if we find how long it takes for one wave to pass through it, which means how long it takes for 5 meter to pass through it, that time is called as time period. We can define in this way, or else we can define in other way also. So we know that in case of waves, the particles will oscillate. So if we draw a transverse wave, something of this kind, and let's look at some particle. For example, let's look at this particle here. We know that each particle will oscillate. Since it is a transverse wave, if the energy moves in this direction, then the wave would propagate in this direction. This particle will oscillate between these two extreme ends. It will oscillate between these two extreme ends. That is, the particle will oscillate between these two extreme ends. So we can define time period from this also, saying that time period is time taken for a particle to complete one oscillation. Even that also accepted, but technically many books will say it is time taken by the wave to traverse a distance which is equal to its wavelength. That's called as time period. The next is frequency. Now time period is given in capital T and measured in second. Next is frequency. We can define frequency in many ways also. So one way here is it is defined as a number of waves that pass through a fixed point in 1 second. So if we look at the previous definition of a wave, we saw that the distance between two consecutive crest or trough was 5 meters, which is called as wavelength. Suppose if you have opening here, if you have small point here, then if we let the waves through pass this point, then if we count the number of waves passing through this point in 1 second, then 1 second if many waves pass through this point, that's called as frequency. We can define another way also, saying that in terms of particle oscillation, we can tell it is the number of oscillations a particle does in 1 second. That's called as frequency. Now frequency is measured in terms of hertz, is given as Hz. We can also prove that frequency is equal to 1 by time period. We'll prove it later. For now, understand that frequency is given as 1 by time period. For example, you all might have heard of something called as tuning fork. Imagine that there's a tuning fork which has a frequency of 280 Hertz, which means if we look at a point here, it means in 1 second 280 waves would cross this point. That's a very, very big number. That's how fast the waves will propagate. So in terms of particle oscillation, if we say that the frequency of this wave is 280 Hertz, which means that this particle will oscillate 280 times in 1 second. That's a very, very big number, but that is possible because of its higher velocity. That's called as frequency. The next definition is called as amplitude. It is defined as the maximum displacement of a particle of the medium from its equilibrium position. This is called as mean position also. To understand this, think for example we have a rope which is, say, fixed at one point. Suppose somebody gives a push to this rope. Then in that case, if somebody keeps on pushing the rope continuously, then here wave is generated in the rope. In this case, we saw that each particle will oscillate about its mean position. That is, particles will oscillate about the mean position like this. Each will oscillate about its mean position like this. So in this case, how much far they go from the mean position, it's called as amplitude. In this case, the particle from here is gone to this position. Keep in mind that every particle in this wave would go to the same mean position only. That is, apparently this particle here is at the mean position. Now this particle later may go like this and also come back to the other end. The particles will oscillate between the two extreme ends. This is called as amplitude. Example, the particle here, this particle is gone to the lower extreme position. It will again go up, and stop and then come back. So every particle will oscillate between the two extreme ends. The distance between the mean position to one extreme end is called amplitude. If this is say 2 meter, then this also will be 2 meter only, but this would be in the reverse direction. It's called as amplitude. Again, this is a very important parameter for a wave because the intensity depends on the wave's amplitude also. Since it is a distance, it is measured in meter. The next one is called as wave velocity. It's common sense that all waves will not have same speed. You all might have learned in school that in case of lightning and thunder, lightning would reach the earth faster and thunder is heard later. That is because of different velocities. So wave velocity is a very important concept. In simple language, it says that it is the velocity with which the waves travel through the medium. Different waves will have different speeds. For example, sound wave itself will have different speeds in case of a solid, liquid or gas. So it depends on the medium also, but for now, in simple language, we can say that wave velocity is the velocity of the wave itself. It's called as wave velocity, and since it is velocity, it is measured in meter per second.